Good morning, students. Today I am going to give a lecture about how to reduce the quadratic form to canonical form by using orthogonal transformation. This is under module 1. We are going to see how the quadratic form to reduce the canonical form. First, we have to convert the quadratic form into matrix form. How we have to convert the matrix form is, what is the formula for that? This is the formula. Coefficient of x square, coefficient of y square, and then coefficient of z square. This is the diagonal value, and this is 1 by 2 into coefficient of xy. Here 1 by 2 into coefficient of xz. Here 1 by 2 coefficient of xy. 1 by 2 coefficient of yz. Here 1 by 2 coefficient of x z, 1 by 2 coefficient of y z. This is the formula for matrix form. Coefficient of x, when first you have to fill the diagonal elements. Coefficient of x1 square, x2 square, x3 square, and this is coefficient of 1 by 2. This is xy. You have to write clearly x, y, z. Here x, y, z. So next, here 1 by 2 into coefficient of xy. What is xy here? So 1 by 2 into minus 4. We are getting answer is minus 2. Similarly, we can form the matrix here. Next, we are going to, as usual procedure, we are going to find the characteristic equation. For this characteristic equation, we need S1, S2 and S3 and S4. S1 equal to, adding these, we get 6 plus 3, we are getting 12. And then S2, the sum of minor of main diagonals. So we are cross multiplying this, 9 minus 1. Here 18 minus 4, here 18 minus 4. We are getting the answer is 36. Next S3 is 32. You can easily calculate determinant of A in your calculator using matrix mode. Next, substitute all the values S1, S2, S3 in characteristic equation. We get lambda cube minus, this is the formula for characteristic equation, and substitute all the values S1, S2, S3 in that characteristic equation. You are getting the equation is lambda cube minus 12 lambda square plus 36 lambda minus 12 equal to 0. Next, you are using your calculator. We go to the equation mode and substitute all the values, that is A equal to 1, B equal to minus 12, C equal to 36 and D equal to minus 32. You substitute all the values in this equations mode. You get the answer is lambda value. Lambda 1 is 8, lambda 2 is 2 and lambda 3 is 2. When your calculator shows that lambda 2 is 2, again you are go to the A. So the last value is repeated. Last value is repeated. Now you understand? Next, to find eigenvector. Each and every eigenvalue we have an eigenvector. Now we are going to perform 3 cases. For each and every eigenvalue, we get a different eigenvector. Next, to find eigenvector, modulus of A minus lambda I into x equal to 0. Next, what is the equation of eigenvector? Eigenvector is modulus of A minus lambda into x equal to 0. This is the base equation. This is the base equation. I am going to substitute that A minus lambda, and diagonal value is minus lambda and the remaining values as it is, and x1, x2, x3 and then 0, 0, 0. Next, in 3 cases we are going to perform. First case 1, let us take lambda value is 8. Lambda value is 8. Okay, substitute lambda equal to 8 in equation. I. So 6 minus 8. 6 minus 8 is minus 2. That is 6 minus 8. That is lambda value. Lambda value. Next, as remaining values as it is, only the diagonal elements only change. Next, we perform the row into column. Form the equation 2x1 minus 2x2 plus 2x3 equal to 0. Similarly, we can form three equations. Now you can see the three equations are different or same. Here the equations are different. So we are going to use cross multiplication rule. Equations are different. So use cross multiplication rule. Okay. X1, X2 and then X3. Just you are start with the middle element, that is minus 2 and 3. Next minus 2, end with the start element. Similarly, this is from first equation and this is from second equation. Minus 5, middle element, and minus 1, minus 2 and minus 5. Now just cross multiplication. Minus 2 into minus 1 is plus 2 plus 10. Next another element is minus 4 minus 2. Next 10 minus 4. So you are getting the answer is x1 by 12, x2 by minus 6 and x3 by 6. Finally, you are dividing by 6 because the eigenvector is very small value. Then only you can easily multiply the matrix in diagonalization. Finally, you are getting the answer is 2 minus 1, 1. Next, case 2. What is case 2? Case 2 value, lambda having 2. So, substituting the lambda, only the diagonal elements only will change and all the other elements are same. So, next same, the same method, form the equation. 3 equations we are formed. Here, see, the equations are same. Both the 3 equations are same. So, I am going to take x1 is 0. Find the other two values. 2x2 plus 2x3 equal to 0. Taking it to another side, minus x2, and coefficient of this come to this side and coefficient of them comes to this side, and x2 by minus 2, x2 by minus 2. Finally, while dividing by minus 2, we are getting the answer is 0, 1 and then 1. Similarly, if this given matrix is the given matrix is symmetric matrix. So, in case 3, we are going to apply orthogonal condition. We are going to apply what? Orthogonal condition. What is the orthogonal condition? x1 transpose x3 is 0, x2 already we find x1 and x3. x3 we don't know. So, we are going to find x1 is 2 minus 1. That you can write this as row wise. That's why we are mentioned here as transpose. 0, 1, 1. So, into element, The same procedure as it is here also we are going to form 2L, row into column. 2L minus m plus n, 0L plus m plus n equal to 0. Equations are different. So, using cross multiplication rule, start with middle value, end with middle value. The same also perform here. L by minus 1 into 1, m by 0 minus 2, n by 2 minus 0. Finally, you are getting the x3 is minus 2 minus 2, 2. Divide by minus 2, we are getting the answer is 1, 1 minus 1. Next, you have to, this is very important step. You have to check the orthogonal condition. You have to check the orthogonal condition. This is very important. X1 transpose X2 equal to 0, X2 transpose X3 and X3 transpose X1. All the three values we know, eigenvectors. So, X1 transpose, you have to write in the row, and X2 is 0, 1, 1. You multiply this, 2 into 0, 0, minus 1 plus 1, you are getting the answer 0. Here also 0, here also 0. Then only the eigenvector is correct. Then only the eigenvector is correct. Otherwise, you have to check the eigenvalues. Next, we are going to perform diagonalization. What is the formula for diagonalization? Diagonalization D equal to N transpose AN. N transpose AN. In last class, lecture class, I explained about how to diagonalize the matrix. Here also same. N transpose AN. What is the formula for that? D equal to N transpose AN. N. First we are going to find N. N is normalized model matrix. Okay. How we are going to form N? The eigenvector capital X1 equal to 2 minus 1 1. 2 minus 1 1. The first column is denote the first eigenvector and the second column is second eigenvector. This is third eigenvector. First, how we can write the first column? This is 2 divided by square root of all the three elements. 2 square plus minus 1 square plus 1 square. This is under denominator. The same thing. Next to minus 1 value. Minus 1 in the numerator and the same in the denominator. Next 1 in the numerator and in the same denominator. Both in one column, all the denominators are same. So go to the second column. Second column is x2. x2 is 0, 1, 1. Capital X2 equal to 0, 1, 1. Okay, 0. 0 divided by root of 0 square, 1 square, 1 square. Similarly, this one, next this one. Next, capital X3 equal to 1 to minus 1. 1 to minus 1. So, you are getting the answer is this one. Next we move on to here 1 1 minus 1. Sorry, here 1 1 1 minus 1. So, next we simplifying this, you are getting n equal to 2 by root 6, 0 and 1 by root 3 minus 1 by root 6, 1 by root 2, 1 by root 3, 1 by root 6, 1 by root 2, 1 by root 3. Next I am going to find out the n transpose, row into column. Next we find out the n transpose matrix and finally we are going to calculate the diagonalization D. D equal to n transpose, this is n transpose and this is A, the given matrix, and this is n. Finally you are multiplying all these three matrix, you are getting the answer as diagonalization, that is triangular matrix only having the eigenvalue in the diagonal elements. In the diagonal elements is eigenvalue 822. This is the final answer of D. Next, canonical form. How to calculate the canonical form? This is the formula for that y1, y2, y3 and diagonalization. Similarly, y1, y2, y3 in the column. Just we are going to substitute the diagonal matrix 8 0 0 2 0 0 0 0 2. Next, multiplying row into column, we are getting the answer is 8x y1 square plus 2y2 square plus 2y3 square. Next, they are also asking in the question, find the nature of the quadratic form. So, find the nature of the quadratic form. What is the nature? Index. Index is positive number of positive eigenvalue. Number of positive eigenvalue. Next, rank is 3. 3 cross 3 matrix, the rank is 3. And then signature formula is 2s minus r. S is index. We are getting 6 minus 3 is 3. Next, positive definite. How we are saying positive? All the eigenvalues are positive. All the eigenvalues are positive. Then it is said to be positive definite. Thank you.